joining the first time. So a couple of us, like my friends and I, we started the study group in the month of December 2021, just because we wanted to learn Rust. And
Okay.
uh, we did the study group for a couple of days, like once every week we used to meet and go through the Rust language book. And we did a couple of chapters. Then we got a grant from Solana, the super team DAO, to study Rust in the context of Solana. Basically, try to go through Solana contracts, Solana programs, and understand how it is written in Rust. So that's how we had an 8-week curriculum, which is focused on Solana programs. The entire 8-week curriculum itself is very focused for like beginner developers. It's not like too much senior devs or even junior devs. I would say probably junior devs, if you are able to go through all the lessons and kind of be able to write your own contract. That's the idea, that you should be able to write your own even simple contract using Anchor or Solana native at the end of the study group. So right now we are in the fifth week. Some of the weeks are extending, like they become 2 weeks, 3 weeks. For example, last week we started the escrow contract, but we didn't have much clarity on the accounts model of Solana. So we kind of, wanted somebody to come in and explain that. And that's how we invited Deep today, who has expertise in Solana programming. And this is week 5. We have 3 more weeks where we will be doing a couple of more contracts. And then we have some bounties associated with the program as well, where if you submit an article describing a specific contract, which can be very easy to read for other developers, then you get a bounty in the Solana USDC, SPL. Or if you by the end of the 8 weeks, if you are able to submit your own contract and show that you have written a contract from scratch and deployed it onto Solana testnet or something, even then you'll be eligible for a bounty. So we have different bounties which is available on our Luma. But this specific period of time that the curriculum that we have designed is for Rust in context of Solana. Basically, Solana in context of Rust. Think of it that way. This is a more like a self-study group, not like a session. What we do in every meeting, we meet every week once, and we go through a couple of articles or something together, and like the contracts together. I will share my screen or somebody else shares their screen, and they will live code along with everyone and just learn the different concepts. So that's the idea. And so today's session is special because for the first ever time we have had a guest speaker from the Solana ecosystem, that is Deep. And Deep, thank you so much for sparing some time of yours this week to basically help us learn a little bit more about the accounts model. I have already shared the blog that we are following, the contract that we are working on. And if you could just maybe should I go through like what points we have done and you can take it from there?
Yeah.
Yeah.
Works.
Okay, that works. Okay. Sure. So let me just share my screen. So we started like from the very basics. Like I think all of these things we are already familiar. Like on Solana, smart contracts are called programs. We have seen this in the previous sessions as well. We understood how this escrow kind of works. That Alice sends asset X to the trusted third party, and Bob sends asset Y to the trusted third party, and then the assets are exchanged. Then for the escrow program, we set up all the basic things like I think we set up the repo. We started the, let me open up the repo. Something else. Study group escrow. Yeah. So we have set up the basic repo where we have defined. So this is not an anchor. This seems to be native Solana. So we use the Solana program from here. We imported the account info, the entry point, and the message public key, etc. And then we also went through that anything that is inside the process, inside the entry point, is the one that gets executed. So then that's the process instruction. In the process instruction, every time we pass three standard parameters: program ID, accounts, and instruction data. Program ID is the specific ID created for this particular program. Accounts are the accounts again related to state and storage, which Deep can share more insights into. Instruction data are basically instructions that will be executed during the transactions. A simple example could be which of the functions would we want to execute that comes through the instructions. So I think this is like the basic setup that we have done, just like very minimal stuff. And we also understood that there are a couple of categories that we can create for like basically to keep the code. Entry point will just have some basic stuff like this, just an entry point to the program. Instruction.rs, where we have the program API that is deserializing the instruction data. So we have the instruction.rs, we are yet to fill this up. Then processor, where we have the logic itself. State.rs, where we have the program objects, what are the different states that are associated with this program. And error.rs for program specific errors. So this is the structure that we kind of understood from here. Then we started the beginning, like basically that, yeah. So now in this beginning, they start talking about there are two system program accounts, and that they will make use of the token program. But I think this entire diagram, again, we are not so clear because we don't have much understanding into like what are these different types of accounts. There's a main account, there's a token account for each of the tokens, that is asset X and asset Y. And then there is a token program, there is a system program. Somebody is owning something, somebody else is owning something else. So Deep, maybe if you can take over from this part, like big accounts model itself, how does it work? What does it mean by ownership? Like, is there a mapping that describes the ownership? Or is it something else? Like, is it just some kind of system storage? Like, what happens? I think this almost everything, like almost most part of this is really about understanding the accounts from what I understood. So if you could cover that part, it would be great.
Okay. So thank you for inviting, first of all.
Sure.
Okay. So let's understand accounts first, right? So like, anyone have any idea what account is? Like, why we use account on Solana?
So I just have some basic understanding, like accounts are used to store data, but I'm not able to relate because I come from Solidity background. So for me, accounts is really like, external accounts versus contract accounts. So it's different in EVM. So I don't understand how accounts store data, but that's
Right.
only the basic understanding I have.
Right. So you can understand account is like a global kind of a heap, right? So it's used for storing data. So this is kind of a perfect thing. So account is used to store data. Now on Solana, we have a now on Solana, everywhere is account, right? So there are there are three main accounts on Solana. The first one is kind of a system accounts, right? And then there is a kind of a executable account, and then we have kind of a native accounts, right? So yep, there are three accounts.
Okay, I'll just write down notes so people want to pick it up.
Yep, sure. So if you talk about kind of a system accounts, right? So systems accounts are basically kind of a those okay, so let's take it a more. So we have three accounts. We have kind of a data, we have kind of a executable one, we have kind of a native accounts, right? And like on data account, we have kind of a two types of data accounts. The first one is kind of a native system accounts, right? Like those accounts which is owned by system accounts, right? So those accounts which are owned by system accounts, and then there are some other data accounts which is basically a PDAs, right? So we'll talk about PDAs further. And the next system and the next account is executable account, which is basically a smart contract account, right? So like on so what happened on Ethereum is like on Ethereum there is kind of a one global heap, uh, and on the same heap we have kind of a smart contract code, and we have a state of those of the contract, right? So but on Solana, smart contract is a different and state is a different, right? So smart contract is stored somewhere else. The state of the smart contract stored somewhere else, right? So these are not connected, right? So they are not stored on a same kind of a storage bucket, right? So they are not stored on a same storage bucket. They are storing on a different kind of a buckets, and then we derive the relationship between all those accounts, right? So this is one of the first thing we need to learn, is that on Solana, smart contracts are stored somewhere else. The
Okay.
state the state of the smart contract stored somewhere else, right?
Okay. Smart contracts. Okay. So when you say smart contracts are stored somewhere else, you mean like the bytecode is stored or something? Like,
Uh, yep, the smart contracts code, the whole kind of a bytecode, the SO wala file.
okay, smart contract code, okay, is stored somewhere else. Okay. And then the you are saying state is stored somewhere else.
Right. So, like if I have to give an example, then there is one kind of a fundamental examples there. So let's take an example of counter smart contract, right? So we created a counter smart contract. The code of the smart contract is stored somewhere else, suppose at the XYZ address. And because this smart contract is responsible for increasing the state of the counter, right? So initially the counter is at 0, and further on the counter will be like 1 2 3 as like a user clicks, right?
Hmm.
So the code of the smart contract stores XYZ, but the state which contain the counters, right? The count which contain the count, the state,
Counter's value, the value of the counter.
yeah, absolutely, which is stored somewhere else, right?
Okay, okay.
Yeah. So in this smart contract, we have two addresses. The first address is a smart contracts one. The second address is the state account, right? Which is storing which is storing the counter's value, right?
So smart contract address is the program ID, is it? Or
Absolutely
no?
right. Yeah,
Yes.
absolutely right.
Okay. Program ID is smart contract address. Okay. Okay.
Right. Now suppose that now like Solana is kind of like Solana market itself as a parallel execution, right? So Solana can execute multiple things at a parallel. So the main reason why Solana says like a parallel execution is because of this, because Solana stores state somewhere else, program code somewhere else. So it gives Solana a power to read account, right? To read accounts multiple times, right? So it can read accounts in a parallel, right? But
Mhm.
it cannot write in a parallel because of they end up in kind of a conflict, right? Who writes first scenarios here, right?
Oh, yeah, that makes sense. Yeah, that's true. Because reading can be like, I mean, reading can just be done in parallel, but writing has, what if there is dependency between the different states?
Yeah,
So that cannot be
absolutely
done in parallel.
right. So we can read, so we can write at a time, right? So we can write just at a single time, right? But we can read multiples, right? So we can read an account from a kind of a multiple executions, right? But we cannot write it. So this is the basic thing, like on Solana is like on Solana, everything is an account itself, right? So there are three type of accounts. Let me summarize it. So there's three kind of account: the data account, the executable account. The executable account is basically a smart contract account, right? And the
Okay.
third one is a native account. So native account, you can say like a stake account, a native loader account, right? Now let's like, understand it, but like a bit more further. Suppose that we created a contract, right? And the address of this contract is let's say XYZ, again XYZ. Now this contract is responsible for kind of a escrow thing, right? So okay, let me talk about the escrow wala thing directly, right?
Yeah. Should I share the screen with the contract?
Yep, you can. Okay, absolutely, awesome. So on escrow smart contract, we know we have to deal with SPL tokens, right? SPL token. And we have to deal with users.
Right.
So each and every users have kind of a address, right? In this address, let's say this user have kind of a 3 soul. Let's say Bob have 3 soul, right? And Elias have 4 soul.
Okay, this address is something like you're saying synonymous to something like my phantom wallet address or something like that.
Yeah, this is a phantom wallet address.
Okay, okay. So each of them have a wallet address. Okay, got
Right.
it.
Now, if you like take a look, what we are saying is that this is a data account, and this data account is owned by system program, right? Because only system program can credit or debit the lampouts, right?
Wait. So each of this, so their wallet address is an account that is created on the Solana blockchain, right? When you
Right.
create a wallet, you're creating an account on blockchain. These are called data accounts, is it?
It's depend, like it depend like what content we are like pushing on account itself, right? So suppose that if we are using an account which like responsible for crediting lampouts or debiting lampouts, right? Then this account is owned by system program itself.
Okay, so what about my, like now I have an account in this Phantom wallet, which I'm using for transferring, say, like something from user A to user B, something. So what is this account? Like, is this a system account? Is this a executable? No, it's not executable, right? Because it's
Right,
not
it's not
running any program. And then third one you had mentioned was which one?
the native accounts.
Native account. So you said that is something got to do more like system level, something around
Yeah, absolutely. We are
program
not talking more
development.
than native accounts. Yeah.
Yeah. So
So
what
like,
is this account that I have now, this address,
yeah, so the
BSBE something that I have?
yeah, so the best way is to copy this address wallet once
Uh-huh.
and open the explorer dot Solana.
Okay, okay. Explorer. Solana.com.
Copy past the address here.
This is a neat trick. I was not aware that we can do like that. DevNet. Okay. Okay, balance is 0. Okay, that's fine.
You are on mainnet, I guess. Like you have some kind of a soul there.
No, not on this, but I have a mainnet. In my mainnet, I have a SPL token. Should I try that?
Yeah, yeah. Just use like any one account which you are comfortable to sharing with.
Yeah, that's fine. It's anyways public blockchain only, right? So, one second. I'm trying to. This Explorer is it is slow. I'm trying to shift to dev mainnet.
Or do a refresh, I guess.
So what is the difference between system account and data account? Or is that a separate type of account, or is it like
Our system account is a part of a data account.
system account is part of data account? Okay.
That's right.
Part of data account. Data account. System account is part of it. Okay. Part of mainnet beta. Okay. I think it's the same address. I may have some SPL tokens. No, just let me check. Okay, yeah, I have in this. So I copy this. Refresh. Balance soul is 0, but tokens should be there, I guess. SPL USDC. Okay, NFTs are here, fellowship invitation. Then here USD coin is there. So yeah, I see this now. How do I know what type of account this is?
Just a second, let me share this address, right? Copy paste this address on like a devnet, right?
Okay. Definitely. Token
Or
history.
should I share my screen? Like if
Yeah,
it's
yeah.
like
I made you co-host. You can share your screen as well.
awesome. Let me share my screen. So it's visible, right?
Yeah.
Right. So you can see this address, right? So this is account,
Yeah.
and account lives on our DevNet. And if you can see, like this account is basically a system program account, right? Because the program ID, like a, and yeah, here is one more important thing, like each and every account is owned by an executable account, right? So this is a system account which is owned by the system program, right? So like here you can see assigned program id is system program, right? So let me clarify it more bit. So each and every account is owned by a executable account, right?
Each and every account is owned by an executable account.
Right, and each and every executable account is owned by a BPF account, BPF loader account, right? Which is again a kind of executable account.
Oh, but is this true for our wallet accounts as well? You're saying?
This is my wallet account, right? This is my wallet account, and this wallet account is owned by a system program, which is a executable account, right? Which is a
Okay.
smart contract, right? So whenever I'm say like executable account, just imagine a smart contract over there, right? So this is a smart contract. So system program is basically a smart contract, and my wallet address is owned by the system program, right?
Okay. So your wallet is owned by that system program. When
Absolutely.
does this happen? Only when you use your wallet to deploy a program, is it?
No, it's just like so suppose that if I'm if I create a new account, right? And
Hmm.
if I transfer some kind of a lamp ports over there, then this account is automatically owned by system program, right?
Oh, is it? I did not know that. So in my mainnet account, I received some USDC, right? That means
Right.
somebody has transferred SPL token to me, but
Right.
it's not showing that it is owned by any system program.
Okay, let me give you one more demo. Okay, so this account have kind of sold, and these are the SPL tokens, right? Weapon. So if I open this in a more user economic way, right? So this account is owned by system program, right?
Correct.
Now this account have many kind of
So
token,
different types of SPL tokens. Yeah.
right? If I click any one of SPL token, so now the owner, there is one more thing which is like very important to understand, like in order to understand the Solana accounts is Solana interchangeably use owner and authority, right? So
Own.
the yeah, so the owner of this account is basically the authority of this account, right? But this token account is owned by token program, right?
This token account is owned by the token program. Okay.
Program, right?
That
But
means if I create a new SPL token, then I am actually creating a new token program. And
absolutely.
if that token program transfers some of that SPL token into my account, that
Mhm.
means my account will now be owned by that token program.
No, this is a wrong analogy. Okay, so let's take a step by step. Okay, so this account is owned by system program, right? It's clear. Now,
Yeah.
now if we click on system program itself, so the system program is owned by the native loader, and like the native loader is a last program which can be ever owned, right? So like no one owns native loader, right?
Got it.
But native loaders own kind of everything, right? If we trace back like every account, then native loader is like a one account which owned all the accounts on blockchain, on Solana blockchain specific, right? So
Okay.
this is yeah. So this is where kind of our uh, what I can say, our trace backing ends, right? So there is, yeah. So this is a final account which owns all the accounts, right? So system program is also owned by this native loader account, right? And no one owns native loader because it's a kind of a default account, right, on Solana. Now let's take a look at token account, right? Let's do this, and this token account, that's just right. So this is a mint account, right? This is a mint account, right? So this like as I said, each and every account is owned by an executable account. So this account is owned by the token program, which is a smart contract, right? And if we see the token program, right, so this is, so this kind of a account is smart contract, right? Token account,
Yeah.
right? And this yeah, and this account is owned by the token program itself, right? And if we select token program, then token program is also owned by kind of a BPF loader, right? So it is owned by BPF loader. And if we see the BPF loader, then BPF loader will owned by the native
Native
loader,
loader.
right? So
Okay.
this clears, right?
Yeah,
uh,
this part is clear. This hierarchy is clear. What I did not understand very clearly is how that particular account is owned by the system program. How
right,
did that ownership come about?
right, okay. So first let's understand this token, right? So it's help us to understand the system program more.
Okay.
So this token program, right? So this is a smart contract. This token program, right? This is smart
Mm.
contract. A smart contract means this is an executable account,
Yes.
and every executable account is owned by BPF loader 2, right? BPF
Yes.
loader 1, BPF loader 2. This is right. Now we are creating a new data account, right? And this data account is a account which is owned by token program. So now token program have authority, like authority of burning, authority of transferring, authority of anything, right? Token program can do anything, right? But it requires signers, right? Because suppose that now this is a token account, right? This is a token account of this account, right? So an account can hold a multiple accounts, right? So this is a kind of a tree structure, right? So there is a one
Yeah.
main token account, and then this account can create or hold many associated token accounts, right? AKA ATA, right? So this is basically a associated token accounts, right? And this is basically a token account, right?
Okay.
Right. So now the authority of this token account is me, right? Because I am the owner of this token account. But here there is a one thing we should notice. There's a difference between authority and owner, right? I'm the authority of this token account, but the owner of this account is this token program, right? The owner of this account is a token program. So suppose that if I want to send you some SPL token, because I am an authority, so I have to sign the transaction, right? But all those debit, all those credit is done by the token program itself. We are not doing anything. We are just signing the transaction. Hey, I'm the authority of this account. Do
Mm.
whatever I said, right? So the token program now doing like anything, crediting, debiting, all this, right? Now let's understand this account. So let's do a quick demo over here. Let me create a new account. Say let's say okay. So now if I open this account on DevNet itself, because this account is not created yet, right? Because so this account is not created yet, but on Phantom it shows that hey there is an sorry, but on Phantom it shows that hey there is a one account, there is one address set which you can use. Now suppose that if I send some lamports, if I send some lamports on this, sorry, if I send some lampo, oh, fuck, right? If I send some lamport to this recipient, let's say one. Now, as soon as I hit next, right? So it send all those transaction. Now it check that now if we refresh this account, right? Now you see this account. Okay, so it's taking some time to.
Yeah, it's taking a while. That's okay.
Let me check. Okay, now it should be done.
Yeah.
Okay,
Oh, now it's come as system program.
right, because this account is owned by a system program, right? And this is a kind of a data account. We cannot use it as a executable account. We cannot use it as a PDA, right? Because this account is created and owned by the system program itself.
I see. Okay. So system program seems like it is something like Solana native kind of.
Yeah, system program is Solana native account, and it is only responsible for handling all the native SOL, right? It's only handling SOL transferring. It's only handling SOL, right? Like I'm sending you some SOL. So what this smart contract does is it's kind of a debit from my account and credit to your account, right? No other smart contract have this capability of transferring all the SOLs. So only system programs have the capability of transferring.
Okay. It's clear
And
now.
yeah, and there is one more catch here, the programs which own the account can only mutate its data, right? So suppose this account is owned by system program, so the system program can debit or credit to this account, right? No other programs can do this. So suppose that this is a token program. Let me see. Right. So this is a token program. This is a token program. So only token program can burn, can edit, can mint, can do anything, right? So only the programs who owns the account can do any kind of a CRUD operation over there.
Okay, got it. Got it. Okay.
Right. So this is the whole thing, right?
Okay. So
And if
CRUD
I
operations can be done only by owner accounts. Okay.
right, if I copy pasta your study material, let me do this quickly. Okay. So okay. So here you can see escrow program. So escrow program is our smart contract.
Hmm.
And as I said, on Solana, smart contracts is different than states account, right? So we are creating a new account which is only responsible for storing the state of this escrow program, right?
Escrow program.
Right,
Okay.
right. States can be anything, right? Like the numbers of transactions happen on this smart contract till yet, right? So it can be anything, right?
Yeah.
Yeah.
Whatever
Now,
values related to the smart contract you want to store, like state variables, basically.
right. Absolutely, right. Now this alias main account, and so like as we saw, like alias main account is like owned by system program.
System program, Bob's
And
main
our main
account
account
also
is
is stored
owned by
by
system,
system
right?
program.
So there is one more smart contract which called token programs, right? Now the token program have their own kind of associated token accounts, right? So
Mhm.
associated token accounts is owned by token program. Associated token account is owned by token account. Same things here, right? Now let's move on a new diagram over there. Yeah. So what happened is that this is a token program, right? The Mint X is actually a token program. Is is a token address which owned by token program, right? Now each and every mint have its own address called a associated token account, right? You can so you can understand this by taking a like a light analogy. So Mint X is basically a bank, right? And each and every bank have their like each and every bank have its customer account, right? So this
Correct.
is a Mint X bank, and this is a customer's account, right? Where all those credit, all those debits happen, right?
Okay,
So
got it.
yep. So like as bank owns the customer accounts, right? And as a banks have authority of credit and debit, but user need to approve the transactions, right?
Correct.
Right. So Mint X. So basically, this token account is owned by the Mint X, right? So this account is not a regular account. This account is a PDA, right? It's a program derived address, right? So the owner of this account is basically the program who created this account, right? So this is a PDA actually, right?
Okay.
Right. And the owner of this token account, basically the owner here means the authority of this token account, right? The authority is basically a user itself, right? The authority is basically a user itself, and user is basically the user account, right? On Solana blockchain, user is basically the user's account, right?
Yeah, like the phantom wallet account or
Yeah,
something. It's owned
absolutely.
by system program.
Right, absolutely. Now this user have X token, this user have some Y tokens, right?
Hmm.
This is an account. Here's one more thing, like account does not necessarily mean like it holds some tokens. Account can hold a zero token, right? But is there, right? The account is there. Doesn't mean like it have some tokens or not, right? So this user have some X token account, this user have some Y token account. These tokens account are owned by Mint accounts, and the Mint account is owned by token program, right? The same thing is happening over there. Like this one have some X, right? So this diagram is clear, right? Any
Yeah,
questions?
this is clear.
Right.
Wait, does anybody else have any questions? I feel like it's clear to me, but what about others?
Yeah.
Please ask folks if you have any questions. I think it's just less number of us. So even if you want to unmute and kind of ask, that's okay. We can make it more interactive. Or you can also type in the chat. Okay, I think we can continue. So are there questions? Maybe they will unmute.
Yeah, let's move further. Now we are creating an escrow program, right? We are creating an escrow smart contract. So basically the whole purpose of escrow is we are not kind of depending on any third party, right?
Correct.
And also we are using on a blockchain. So what we can do is we can create a new token account which is owned by our smart contract, right? So a new token account for X and a new token account for Y, right? So we are creating a two temporaries account which is only used to hold some X tokens, some Y tokens, right? Now Elias transfer his X token to the token account which is owned by a smart contract, right? And Bob transfer his Y token to the Y token account which is owned by our smart
contract.
Right now, like as soon as we receive all those contracts, right, and any users like hit a claim button, right, we can check we can check there is a Y token and we can check there is X token, and then we can swap those token, right?
Yes, from this account we will have to send it to, like, from Alice ka account. If they send to the like X token, then once they claim, we send the Y token to Alice's Y token account, and from the X token we send to Bob's X token account.
Absolutely. Now here's a one thing why I'm saying that X token is owned by our smart contract, because we need to approve the transaction, right? Now in this case, uh, the token account, the X token account is owned by our smart contract. So our smart contract can sign the transactions, right?
Okay.
So this is the main thing why we are using an temporary PDA, right? So basically, this is a program derived address, right? A token account is owned by system program, and any account which is owned by a system. Sorry. Here I did one mistake. Any account which is owned by smart
By the
contract
program itself, any account owned by the program can
is
sign
called PDA.
transaction.
Yeah, it's called PDA, right? So
Yeah.
any account which is owned by smart contract is called a PDA. And now because the account is owned by the program, now the program can sign the transaction on behalf of the account, right? So we don't need any humans, right? We don't need any human over there.
Interesting. Yeah.
Right? So this flow is same. So we are creating a new temporary account X, which is owned by our smart contract, right? Now because our smart contract own this transaction, so like according to our business logic, at the end of the like our validation, he can approve the transfer of the account, right?
Got it. But here, this temporary token account, if it is a temporary token account, won't it be owned by the token program?
Yeah, it is owned by the token program, but we have an authority, right?
Authority.
Yeah.
Okay.
So this is like one of the biggest backslash of a Solana. Like it's uses a confusing term, right? It's using a authority owner, right? So
Yeah.
yep. So this diagram is also clear, I guess. And these are all okay. So okay, there is anything? Nope.
I think, yeah, I think the first initial ones are clear, at least from what we understand. Maybe what we can do is, like, we are almost now, like, almost 1 hour. We have 10-15 minutes. Maybe Deep, if you would be available next week or anytime next week, maybe even if not Tuesday, what we will do is we will go back and do these parts, like at least we'll understand a little more about the diagram and such, like how the accounts are being created and the code related to that. If you have time next week, can I request you to come and explain the PDAs as well? Because I think that's also something that is little tricky, and maybe because you seem to have a lot of experience, you can be a better like teacher to
Uh,
kind of.
like I'll let you know like about my calendars, right? And then we'll
Yeah.
figure out the time. Mm.
Yeah, you can let me know what your calendar is like. Every Tuesday, like this one 6:30 to 7:30 is there. If you're available next Tuesday, then I can invite you. Maybe we can make it shorter so that you don't have to do that much time and just cover like PDAs proper, like just 30 minutes or something.
Right.
And yeah, if not, you can let me know according to your calendar what is your preferable time, and we can kind of meet at that time.
Yep. Sure.
Awesome. There are few folks who have also joined the group today. Does Akira and Than, do you have any questions? Like Deep is there with us, and we have about 5-10 more minutes. So if you have any questions, feel free to ask. Okay. So Deep, if you have any online material on the topics, like mostly around the accounts model, could you share anything, or maybe even you can share it to me later on Discord as well, and I can share it with folks as a.
I guess there is one more. Wait, just yeah. So there is one reference which is highly recommended, as going all through the Solana cookbook itself.
Okay.
So Solana cookbook is very kind of a dense on the account itself, right?
Yeah, it's a little dense. That's why I think it's a little different, like to imagine the mental model,
Yeah,
especially if you don't, if you're new to blockchain, maybe it's easy. But if you come from a solidity background, I think the naming, the terminology, it's a bit
yeah,
difficult to kind
agree.
of imagine that mental model. So that's why we are trying to invite people who have worked on this. So because you have experience in both EVM and Solana, you're
Right,
also able to kind of differentiate and show us that this is what this is how you should think about the mental model. So this was very, very helpful. I will also post this resource on our Rust study group. I am happy to invite you to our Telegram group as well. We have a Rust study group for Telegram. If you do have time, please join the group. And if there are any questions, maybe people can post on the group as well. I've recorded the session, so I will be sharing that. And of course, I have made some notes, and I will try to share those notes as well. Uh, and yeah, thank you so much, Deep, for your time. Like, we really, really appreciate it. And we hope if you have some time, maybe you can also do the PDA session. I think then more or less we are sorted, right? Like with the basics. So we are good to go, at least be able to write a contract ourselves, you think?
right. So basically the main way to learn like anything on Solana, right? It's just by practicing. So
Yeah.
yeah. So like as I shows the demo, right? The kind of a PDA, kind of a system program owns, right? The whole native loaders thing. So now what you can guys do is go and create kind of a one PDA, and there is a whole bunch of a resource over there. And like on next week, I guess I'm hopefully like I'll kind of a live code, right? So kind of a live code the whole things, so it make more things much clear, right? So
Yeah,
the
that's
yeah
very useful. Sorry, what you were saying something. If I
no problem, no problem.
Yeah, sure. So we have shared actually the Anchor book has a chapter on PDA. So we had shared that chapter earlier in the group, but I think not many people were able to catch up because we were lacking this basic mental model of accounts
Right.
itself. But now that this is clear, I think we can look more into like now we really understand how the hierarchy kind of thing is working. So when we think about program derived addresses, accounts, at least we can think like how the tree structure will look like, and
Yeah, absolutely.
how it will, the authority ownership, how it works, and what is the use case. I think it is more clear now. Do you recommend, Deep, from your experience, because we have been doing a mix of Anchor plus native, but native contract we did not do much. I think we did one, which was very simple. And then we are trying to do a lot of more of Anchor stuff. Do you recommend doing lot of native ones over Anchor, or what is it in your experience?
Uh, no, I just recommend do one Solana raw program, right? So you can understand the kind of instruction. You can understand why we use just one entry point, right? Why Solana have only one entry
One
point.
entry point, yeah.
Right. So there is a logic of using only one entry point, and why there is only three arguments: the account info, instruction, and the program ID itself, right? So
Yeah.
if you do just one Solana raw contract and understand every bits of the contract, right, then I'm like pretty much sure you can able to grab all those mental models and just jump on Anchor itself, right? Don't spend too much time on Solana raw, right? Because Solana raw kills your productivity, right?
Yeah,
So
yeah, it's a lot of work in terms of navigating the
yeah, so
code.
just do one Solana program raw, try to understand every bits of it, like why it is happening, why it is not happening, and then move on Anchor, right? And on Anchor there is a one specific command which is anchor expand, right? So this command is very helpful to understand like everything of this.
Okay. Anchor expand, is it?
Yeah, it is similar as a cargo expand, right? If you are familiar with the Rust.
Yeah,
So
yeah.
yeah, so it's similar as a cargo expand. Let me write quickly on chat itself if you guys need. So this is very helpful command.
Okay. Great. Okay. Awesome. Yeah, I think this is great. We'll work on the escrow contract itself, the whole blog. I think it's a longer blog. It has a lot of different elements. So we'll
Yeah,
go through the theory and then even the program derived accounts. And maybe we'll try to do one small example of program. I think there's that Puppet example. That's, I think, program derived accounts. Or no, no, that was CPI. Sorry. Cross
so
programming.
my suggestion is my suggestion is stop reading this blog now, because the whole thing of this blog is understanding account, right? And I hope like I was able to explain the whole kind of mental models of account. Now stop reading this blog because it kills you, like literally it kills you. Do one thing, do a escrow program by Alan, right? By Alan, and the escrow program is itself on Anchor, right?
Okay.
So yeah, so it helps you to connect the whole kind of a PDA. Why I'm talking about executable accounts, data accounts. So yeah, so do the Alan once of the escrow and stop reading this one.
Okay, cool. So we'll take a look at that. Alan, escrow program by Alan. And then,
Just I'll quickly share it with you if you want. Just
okay, if you have, that's great. These resources. Solana cookbook.
this one. Mm, Yep, this one.
I,
Rihanna, can
Yep,
you please help
this
with the name of the program? Okay.
okay, GitHub, Anchor escrow. Okay, great.
yeah. So take a look at this smart contract, like and try to understand how it is working. Like
Okay,
if you right. So if you understand this session, right? If you understand this session, then the understanding of the escrow account by Anchor, right? But the
hmm.
Alan in Anchor is pretty much clear.
Okay, cool. Okay, so we'll definitely attempt this program before the next session. And then if you have any questions, we'll come back and I'll wait for your calendar to book some slot sometime next week for the PTA session.
Okay, awesome. I have to leave. So hopefully
Awesome. Yeah. Thank you so much, Deep. Thanks